At the core of machine learning, we have a lot of data, come up with some model. Using this data and this model, we can actually train repetitively on this data so that our model can learn something from that data. Once we finalize this learning process, if we have a new sample of data, we can actually input that data into our model and it'll spit out some result. So today in this video, we'll talk about what is machine learning and how that compares to data science and AI. And then we'll talk about the different types of machine learning and the tasks associated with those. So let's first start off with what is machine learning. Well, machine learning is a subdomain of computer science that focuses on algorithms which help a computer learn from data without explicit programming. So what that means is we want our computer to be able to go through a large data set and be able to find patterns in this data set by itself without us explicitly telling the computer. So for example, if I wanted to know whether or not an image contained a hot dog, explicit programming would be us, the programmer, saying, okay, if there is a bun in the image, and then if there is, a hot dog in the bun, and if there's like relish or mustard or, whatever you want to put on your hot dog. And so if all of these things are true, then it's a hot dog. But we as a programmer in machine learning are not going to be telling our computer these things. Instead, we are going to be just giving our computer, hey, here's all the examples of a hot dog. Here's all the examples of something that's a not dog. So not a hot dog. Here's all the things that are not a hot dog. And I want the computer to be able to learn from these two images, compare the pixels in these two different data sets, and eventually be able to find out for itself, hey, what's a hot dog and what's not a hot dog? Or I should say, in an image, what contains a hot dog and what does not contain a hot dog. So that's what it means when we say without explicit programming. How do AI and data science compare to machine learning? Well, artificial intelligence is also an area of computer science, but here the goal is to enable computers and machines to perform human-like tasks and to simulate human behavior. So artificial intelligence here is very much emphasized on human replication. So if we think of all these AI tools like ChatGPT and AI essay writers and stuff like that, what we're trying to do is actually replicate what a human would be able to do. So it's artificial human intelligence. Now, machine learning, on the other hand, machine learning is the backbone of AI. And so we use machine learning to develop AI tools and these AI models, but there's a slight difference that AI is actually a subset of machine learning. And AI is something that takes a machine learning model and applies it to mimic human intelligence. Whereas data science is a field that attempts to find patterns and draw insights from data. And when we're doing these things, we might actually use machine learning, but we're not just limited to that. Data science is kind of just the science of working with data and trying to figure out what the data is trying to tell you. And then now machine learning can come in and make predictions from that data. The bottom line is all of these fields do overlap, and all of them to some extent do use machine learning. At the core of machine learning, we have a lot of data and we come up with some model. And now using this data and this model, we can actually train repetitively on this data so that our model can learn something from that data. Once we finalize this learning process, if we have a new sample of data that we know nothing about, that we haven't seen at all, we can actually input that data into our model and it'll spit out some result. And this is the essence of machine learning in a single sentence. There's a few different types of machine learning. The first type of machine learning, and the most broadly known and most popular type of machine learning, is called supervised learning. And in supervised learning, we use labeled inputs to train models and learn outputs. By labeled inputs, I mean our data set consists of a bunch of inputs. So we can think of these as maybe a bunch of different animal pictures. But all of these pictures, all of these images will have a label already associated with it. So, if we have a cat image, we already have a label saying, oh, this is a cat. If we have an image with a dog in it, then we already have a label saying, oh, there's a dog in this image. And that's what a labeled data set means. It means we already have the output, the desired output of the task that we want to do associated with our input data. Now, the second type of machine learning is known as unsupervised learning. And in unsupervised learning, we don't actually have these outputs. So we're using unlabeled data to learn about patterns in the data. One example might be, okay, if we have a data set of, different numbers, then we might want to cluster these, pieces of data and try to actually say, oh, all of these data sets with these numbers are very similar, and that's one cluster. Whereas maybe this other thing is very similar and that's another cluster. So for example, if we were classifying different types of fruits, some metrics that we might have available in our data is the weight of the fruit and the circumference of the fruit and the color of the fruit or something like that. And maybe based on the weight and the size of the fruit, we can actually cluster these into, okay, these types of fruits are melons and these types of fruits are berries. But our computer just wouldn't have that output label. So we would have category 1, which us as a human can look at and we can be like, oh, that's a melon. And then we have category 2, which then we can look at and be like, oh, that's a berry. So maybe if we have another fruit, mystery fruit, and we want to see if it's, more similar to a berry or a melon, we can go and use these metrics in our unsupervised learning model, and we can figure out if it belongs to category 1 or category 2. And now the final type of machine learning is known as reinforcement learning. So in reinforcement learning, we are actually trying to teach an agent in an interactive environment based on rewards and penalties. And by agent, that just means some entity in our virtual world that's trying to learn in some environment. And so often these are gameplay agents. So maybe you're trying to get a car to drive optimally in Drive Mania. That would be an example of reinforcement learning because we don't actually have the answers of what is right and what is wrong. There is no right and wrong action at a single point in time. Instead, what we want is to achieve our end goal of going around the track, not dying as fast as possible. So that's reinforcement learning. And reinforcement learning is actually very similar to training your pet. So it's kind of like the computer is your dog, and you can teach the computer how to act and how to behave by giving the computer treats or, telling the computer, hey, bad dog. But in actuality, these treats would actually be positive numbers and the penalties are just negative numbers because that's a language that our computer can understand. There are a few different tasks that we try to accomplish with our models in machine learning. So these are going to be the outputs, the predictions of our models. So the first type of supervised learning task is known as classification. And in classification, we're trying to predict discrete classes. So these are discrete categories of items. So for example, we might have different types of foods and we want to predict categories that the input image might fit. So in this example, let's say we have a hot dog and a pizza and ice cream. So we're gonna pass these images into our model and the output that we're trying to get is what type of food is this? So that food might be labeled as hot dog, might be labeled as pizza, might be labeled as ice cream. Now that is something called multi-class classification. Other examples of multi-class classification might include Okay, I give you a bunch of statistics about a plant, and I want to know what type of plant species that is. There are so many different classes of plant species out there. So yeah, I want my model to take some statistics and tell me what it is, which one it is. Another example might be a bunch of different images of cats, dogs, fish, all different types of pets. And I want my model to be able to look at these images and tell me which class it fits under. So, is it a cat, dog, fish, etc., hamster? I don't know. What that means is there are many different types of classes, and we're trying to figure out which one it belongs to. There's also binary classification. And what that means is we only have 2 classes, and we're just trying to get which one does it fit in. And so one example of that might be hot dog and then not dog, not hot dog. Other examples of binary classification might be, hey, am I positive or negative for COVID? Or does this image contain a cat or a dog? Or does this email, is this spam or is it not spam? So in all of these, there are only 2 categories. That's binary classification. It's one or the other, and we want our model to tell us which. On the other hand, the other type of output that we can predict is numerical. So that's known as regression. And that's when we want to predict continuous values. So an example of that could be, what is the price of Apple stock, a week from now? Or what is the price of a hot dog? It could be, what is the value of a house given all of these different metrics of the house? How many bedrooms it has, what square footage it has, like what the zip code is, and all of these other attributes. We could also be predicting, how much snowfall will we get tomorrow? Or how many cars might be driving through this intersection given some time of day and day of week. These are all forms of regression, meaning we're trying to pinpoint a value on a continuous scale rather than just, hey, there are these, 5 categories and it has to be one of those. These machine learning concepts that we learned about in this video, this is the basis of most of the machine learning that is out there in the world today. And most of that machine learning is what AI is built on top of. Be sure to subscribe to follow along and drop a comment below if there's anything that you would like to see me teach in this series.